Okay, so I want to talk about section 1.2, which is really like, why do we do this number thing anyway? And so the first place, right, that you would go to with numbers, in fact, the first thing we teach little kids is that you want to count stuff, right? So at some level, that's what numbers started with the idea of counting, right? These are sometimes also called the natural numbers, the sort of first set of numbers. And we give them a label, this fancy capital N. And we all know those are the numbers 1, 2, 3, 4, and kind of so forth, right? And really what we're thinking about there is we're thinking about this is a way to keep track of like objects. And because I can't draw goats, which I think are probably the first thing that people care to keep track of, I draw sheep. They look kind of silly, but that's really what we're thinking. We're thinking these are labels, right, for quantities of sheep. Like this first one, that represents one little sheep out all by itself in a field. This number 2, that represents 2 little sheepies together out in a field. Right? Cool? So, sheep in a field, you're just labeling a quantity. The next thing we're going to think about is we're going to think about whole numbers, right? And so whole numbers, and this took an embarrassingly long time, just add one thing to the natural numbers, or the counting numbers. They're represented by this capital W, naturally. And the thing that they add is 0. And we still think about sheep, but when we think about sheep in terms of the whole numbers, what does this 0 represent? Yeah, that's exactly right. It represents not any sheep out in a field. And for some reason, that took a really long time for humanity to come up with. 1 still represents the same thing that it did before, right? It represents a sheep. 2 still represents the same thing it did before. It represents 2 little sheep. And 3 and so forth, right? So all we've done is add one symbol and made a new label for there aren't any sheep. So then you might think of the next one, which is the integers. And those we give, of course, the natural letter of, yeah, you guessed it, Z, of course, because why not? Really, because the German word for integer starts with a Z, but whatever. So we have integers, and those we represent as, well, really, we think about the whole numbers, and then we think about what if we wanted to count deaths of sheep? Or what if there were anti-sheep? And so that's really what we're thinking here. We're thinking either there's sheep or there's a quantity of anti-sheep, right? And anti-sheep being the thing that you combine with a sheep to get nothing. Okay, so those are our labels. Like here when we thought about -1, what we'd think of is 1 anti-sheep. Here what we think about as 1 sheep, right? And if we combine these two things, we would be here at no sheep, which we still think of as there aren't any sheep in the field. Okay, so the next one you might think of is the rational numbers. And those rational numbers and this Q, these are words I'm not really a huge fan of. Maybe what we should really think about here is that these are fractions, right? And why do fractions come up naturally? Well, you might think about taking some sheep, right? A herd of sheep or anti-sheep that you have from the integers. And you might think about, well, how do I split that amongst the people in the village, right? What's everyone's share of a sheep? Well, that here is really what we mean, right? So when we write a fraction, we have a number in the integers, and we're going to divide by a counting number. And what we're going to get, right, is the kind of concept of sheep or anti-sheep herd, right? Allocated among, that's really what this division bar means, some people. So we might think like, when we see an M over N, we might think M sheep split by N people. And this is the amount of sheep that each person gets or is responsible for, or however you want to think about this. The next one you might come up with is the real numbers, which is this capital R. And it's a bit of a stretch to see where this came from. This actually took a really long time to get from fractions to decimals, and it's not an easy stretch by any means. So I'm going to gloss it a little bit, and I'm just going to say that the reason that we thought about the real numbers was that we wanted to do decimals. That in and of itself maybe doesn't make a ton of sense, but really what we think about decimals as this number line, right? So what I want to do is I want to quantify kind of distance, and distance, and this is the stretch, distance doesn't have to be a fraction. Distance can be anything. And that's a bit problematic. It's a little bit weird, and the Greeks actually killed people over this, that there are distances that aren't rational. So one of the ones we know about this is like pi, and those are called irrational numbers. So that's really what we added to go from Q to R. We added this idea of, oh, well, there are these irrational numbers. And what the irrational numbers have that's special, so we might kind of look at the irrationals and we might think, oh, okay, that's numbers like pi or other numbers that we don't know about yet. But there's a bunch of these. And what they have that the fractions don't is when you write out a decimal expansion for the fractions, it eventually has a repeating block. For instance, a decimal expansion for this, for a number in here, might look like 1/3. I'm sure you all can tell me the decimal expansion for a third. It's 0.33, right? Repeating. There's your repeating block. That 3 repeats. It's possible for that block to be more than one number long, but if it's a fraction, it's always going to have that repeating block. These guys don't need to have that property. I'm sure you all know that pi has no repeating pattern in its decimals. But there's others that are easier to see, like maybe we would think about 0.10, 100, 1000, 1000, and kind of so forth, right? So what am I going to put next? Well, I'm going to put 1 and then 5 zeros, right? So there's a pattern. You know what the rest of this decimal expansion looks like, but there's no repeating block because there's always going to be bigger spaces of zeros out there. So this thing here is an irrational number like pi. And we could make lots more of those. It should be obvious that we can make tons and tons of those. Okay, so the next thing that we have to do is we have to think about what are the operations that I do between these things. I just want to give you a little story feel for the operations. So you guys know about addition. So what do I mean when I add things? Well, really I mean I combine those two numbers, right? And this makes worlds of sense in terms of the integers, right? If I tell you about, okay, I want to write a story about 3 plus -2. What's the story that goes with this? Well, you might think to yourself, okay, I know what 3 is. That means that there's 3 sheep. Sheep have legs, for real. Okay, so there's 3 sheep. That's represented by 3. And then what does the and mean? Well, it really means and, right? Plus, and also -2 sheep. So what's -2 sheep look like? Well, that looks like a little herd, right? Of 2 anti-sheep. So when I combine my 3 regular sheep and 2 anti-sheep, what do I get out of this? Well, I think I get 1 sheep left over, right? And I'm really thinking about that as, right, this guy is 1 regular sheep, and then 2 of these sheep, anti-sheep pairs. Sheep, anti-sheep. These guys are 0, right? Those pairs. Because there's no sheep there, right? There are a sheep and an anti-sheep. They combine, obliterate one another. Ooh, violence, my bad. they combine and disappear. So I'm left with one sheep here. Does that kind of make sense? Please note, I didn't tell you how to subtract, right? The reason I didn't tell you how to subtract is I don't actually like thinking about subtracting. I don't like you guys to think about subtracting. I like thinking about adding negative numbers. So I can just talk about sheep and anti-sheep being combined. If I talk about subtracting, then I have the possibility that someone could take away more sheep than there were, and that would be weird, right? So that's our addition. We actually already covered division, right? That's right here. That's dividing things amongst a group. So the other operation I need is multiplication, which I want you to write as dots, not x's, because we're going to use x's all over the place here. So my little example for multiplication might be like, okay, what if I did 4 times 2? What do I mean by this? Well, I want you guys to think this way. So I want this first number to be 4 groups. And then I want this second number to be the number of things in each group. So I'm going to have 4 groups of 2 things. So if I wanted to draw this, right, I'd draw 4 groups. Okay, there's a group, there's a group, there's a group, there's a group, right? And how many things do I have? Well, I'm going to draw sheep because that's all I can draw. So I have 4 groups of 2 sheep each. And I wonder how many sheep are in my little herd here. Well, I'm sure you guys can see there are pretty clearly 8 sheep in my little herd here. So that's our answer, right? And the only thing we did, right, this simplification step from 4 times 2 to 8, was a regrouping, right? I thought about 4 groups of 2 things each as 8 groups of 1 thing each, or 1 group of 8 things each, right? Okay, so this is just a basic, like, here are numbers. I want you to remember where they came from, and I want you to allow the possibility, and this is a little bit of a stretch, that maybe we aren't done, right? So there might be, right, at each stage we added a new thing, right? We went from the natural numbers, we added 0, we got to the whole numbers. We went from the whole numbers by adding a minus sign, we got to integers. We added this concept of split amongst, right, to get from integers to rational numbers. Then we filled in some decimal expansions to get to the real numbers. Maybe there's a way that we could get to someplace new. That's really kind of the abstraction of math, which is really cool, that there might be a new place.